China just closed the final gap on a giant new Yangtze bridge, one that stacks a 6-lane highway right on top of bullet trains screaming along at 350 kilometers an hour, over a river everyone said was impossible to cross. Here's how they pulled it off. Picture the Yangtze River near its mouth, just outside Shanghai. Down here, the river is so wide it feels more like the sea. And it's crowded. We're talking close to 200,000 cargo ships pushing through these waters every single year. Container ships, oil tankers, bulk carriers stacked to the sky. So any bridge you build can't have legs sitting in the shipping lanes. The boats need a clear, towering gap to sail under. That's challenge number one. You have to leap the whole channel in one giant jump. Now here's the part most people do not think about. The ground under this river isn't solid rock. It's soft, squishy even. After thousands of years, the Yangtze has dumped layer after layer of mud and silt into its own mouth, creating a riverbed of soft clay that goes down dozens of meters. Try building a heavy bridge tower on soft mud, and you've got a problem. It's like trying to stand a brick on a wet sponge. It tilts, sinks, or cracks. So the engineers couldn't just drop a foundation in and hope for the best. They had to drill deep, and they had to drill into the bottom of a moving river. Here's how they beat the soft riverbed, and it's pretty wild. To anchor the two main towers, the crews drilled 152 enormous holes straight down through the water and into the clay below. And these weren't little holes, each one was 2.5 meters wide. That's wide enough to park a car inside, sideways. Then they filled them with concrete and steel to create deep roots that grip the ground far below the soft mud, all the way down to where things are stable. They're clustered under the two giant piers that hold up the main span, the two pillars carrying the heaviest load on the entire bridge. So under each one sits a forest of these concrete roots, working together to spread the weight and keep the towers from leaning even a hair. But there's a catch with soft, watery soil. When you drill through it, gaps and pockets can hide at the bottom of each hole, weak spots you can't even see. So the team used something called intelligent grouting. In plain English, they pumped a special liquid mix into the bottom and the sides of every hole, and used sensors to make sure every gap was sealed tight. Think of it like filling a tooth. You don't just want the surface patched, you want every hidden pocket sealed, so the whole thing holds for decades. And here's what makes it impressive. This was the first time anyone in China had used this kind of smart sealing on both the bottom and the sides of the piles for a railway bridge. So while the crews were building the foundation, they were also inventing the method to build it. Now remember, none of this happens on dry land. Every drill, every pour, every sensor reading takes place out on open water, with the current tugging at the equipment and ships passing nearby. Get something wrong deep beneath the river, and you might not find out until the whole bridge is already sitting on top of it. That's the kind of pressure these crews worked under, day after day. With the foundations locked into the riverbed, the real magic could begin, building the deck out over open water. This is the scary part. You're not building on the ground anymore, but sticking a giant steel arm out into thin air with nothing under it but rushing water and passing ships. So how do you build a bridge over a gap you can't put scaffolding in? You build it from both sides at once, piece by piece, reaching toward the middle like two people on opposite cliffs, each laying a plank ahead of themselves, slowly walking out to meet in the air. To lift those massive steel sections into place, the crews used two cranes that could each hoist 1,100 tons. To put that in perspective, that's like picking up roughly 200 grown elephants and gently setting them down with the precision of threading a needle. And precision is everything here. When the two arms finally reach across that side, have to line up almost perfectly with the holes on the other. We're talking millimeters. Get it wrong and the two halves don't meet. So smart monitoring systems watched every steel beam in real time, tracking the exact position, the stress, even the tiny way the steel bends in the sun. The computers nudged the lift operations along until both sides lined up. Quick pause before we get to the part nobody talked about for this project. Videos like this one take hours to research, write, and produce. If you're enjoying it and want to help keep them coming, there's a link in the description and the pinned comment where you can make a small donation, completely optional, no pressure at all. All right, back to the bridge. Now, let's talk about what makes this thing so special. Most bridges do one job. They carry cars or they carry trains. This one does both by stacking them like a double-decker. On the top level, a 6-lane highway, built for cars cruising at 100 kilometers an hour. On the bottom level, the railway, and not just any railway. This deck carries high-speed trains that hit 350 kilometers an hour, plus slower intercity trains at 250. That makes it China's first bridge across the Yangtze, designed to let bullet trains fly across the river at full speed. With a 400-meter gap to cross, there's no pillar holding up the middle. There can't be one, or it would block the ships sailing through. So what's keeping the road and the trains up over all that open water? Cables. Steel cables fan down from the tall towers like the strings of a giant harp, each one gripping the deck and pulling it skyward. The entire roadway is basically hanging in the air. Now stack the trains onto that. A loaded bullet train can weigh hundreds of tons, and it doesn't sit politely in one spot. It sweeps across the whole bridge in a matter of seconds. Imagine a heavy weight rolling across a tightrope, while you're trying to hold the rope perfectly still. That's the puzzle these engineers signed up for, and it gets harder, thanks to that smooth concrete track down below. Remember, there's no gravel to soak up the jolts. Ballastless track only works if the surface beneath it stays almost perfectly flat and steady. Bend the bridge even a little, and a train doing 350 would feel every ripple. The trouble is, a bridge this long naturally flexes in the wind, stretches in the summer heat, and dips under heavy weight. Solid ground does none of that. So the team's real challenge was to make a 4-kilometer bridge behave almost like solid rock. The chief designer described carefully tuning the bridge's height and structure to hit a delicate sweet spot stiff enough that bullet trains glide across without a wobble, yet flexible enough to ride out wind and weather for decades. Lean too far either way, and the whole thing fails. There's one last clever touch. Out on the bridge, the highway and the railway run together, sharing a single crossing to save precious space over the water. But at each end, they peel apart and fan out cars flowing onto one network, trains onto another. One structure carries everything across the river, then quietly hands the traffic off in two directions. Pulling all of that off on a bridge this long stretched far out over open water, fighting wind, heat, and the weight of the trains themselves, that's why engineers are calling it the largest road and rail cable-stayed bridge of its kind in the world. So far, this is an amazing story about steel and concrete. But here's why millions of people will actually care. Right now, if you want to travel by train from Shanghai to a city called Qidong, just across the water, it takes about 2.5 hours. You have to go the long way around. Once this bridge opens, that same trip drops to under 30 minutes. Stop and think about what that does. A 2.5-hour journey was a whole day commitment. A 30-minute hop is just a normal morning. Suddenly, towns that felt far apart start behaving like neighborhoods in the same city. People can live in one place and work in another. Businesses on opposite banks can trade like they're next door. Picture how that reshapes a normal life. A nurse could live where the rent is cheaper and still make it to a big city hospital before her shift starts. A workshop on one bank could get parts from a supplier on the other in the time it takes to finish a coffee. A family split between two cities could sit down for dinner together on an ordinary weeknight. When a crossing shrinks from hours to minutes, it quietly rewires how a whole region lives and works. This is the real goal. The Yangtze River Delta around Shanghai is one of the most powerful economic regions on the planet, and China wants to stitch its cities tightly together so goods, workers, and money can move almost without friction. This bridge is one more thread pulling that giant web closer. And it's part of something much bigger, a high-speed rail corridor stretching all the way from Shanghai inland toward Chongqing and Chengdu, deep in the heart of China. One missing piece at a time, that line is filling in. And the river itself is the spine of the whole story. The land running along the Yangtze is packed with people and factories, a kind of economic backbone stretching from the coast far into the country's interior. Every new bridge and rail link that ties the two banks together makes that backbone stronger, letting people and goods flow faster and cheaper across one of the busiest economic regions on Earth. A single bridge sounds small next to a goal that big, but this is exactly how these giant plans get built, one impossible crossing at a time. If you made it this far, thank you. Genuinely. These documentaries take a lot of time to research, verify, and put together properly. If this kind of content is something you value and want to help support, you can make a small donation through the first link in the description or the pinned comment. No pressure at all. But every contribution helps make the next one possible. Closing the main span is like finishing the skeleton. Now comes the rest. Laying that ballastless track, building the road surface, wiring up the power and the signals. The crews are targeting late 2027 to open the whole thing to traffic, which leaves one big question hanging over the water. China is now crossing the impossible parts of the Yangtze on a regular basis. So if a river this difficult can be conquered with stacked highways and 350-kilometer-an-hour bullet trains, What's the next barrier they're already quietly drawing up plans to beat? Let us know what you think in the comments section. Now, the next crossing China wants to build isn't a bridge at all, but a tunnel. Instead of going over the water, they're planning to go straight under it, burying a $100 billion passage deep beneath the Bohai Strait. I dug into the whole plan in the video right here, so come check it out, and I'll see you on the other side.